What if the cable snapped? Right now. You step inside. The doors slide shut. The numbers begin to climb. 10 floors, 15, 20, and for a brief moment, a thought crosses your mind. What's actually holding this box up? It feels effortless, smooth, controlled. But you're suspended high above the ground inside a metal cabin, relying on cables, pulleys, motors, and invisible systems you never see. So why don't elevators just fall? And if something fails, what stops a disaster? Today, we're pulling back the walls of one of the most trusted machines in modern life. Welcome back to Simple Things Why and How, where we uncover the hidden engineering behind everyday experiences. Elevators feel ordinary. You use them without thinking, in offices, apartments, hotels. But behind that quiet ride is one of the most carefully engineered safety systems ever designed. Because here's the truth. Elevators are built with multiple layers of protection, not just one. And almost every fear you've ever had about them was solved more than a century ago. First, let's address the biggest fear. The cable snapping. Modern traction elevators don't hang by a single rope. They use multiple steel cables, often 4 to 8 thick cables woven from strong steel strands. Each cable alone is capable of supporting more than the entire weight of the elevator car. That means even if one cable somehow failed, the others would still hold the cabin safely. And cable failure itself is extremely rare because they are inspected regularly and designed with enormous safety margins. But even if the impossible happened, there's something else waiting. In 1854, a man named Elisha Otis stood on a platform high above a crowd in New York City. He ordered the rope holding the platform to be cut. The crowd gasped. The rope snapped. The platform dropped, just a few inches, and then locked in place. Otis had invented the elevator safety brake, and that invention changed architecture forever. Without it, skyscrapers wouldn't exist. Elevators run along vertical guide rails attached to the building structure. If the cabin begins moving too fast, especially downward, a device called a governor detects the overspeed condition. When triggered, the system activates strong mechanical brakes that clamp onto the guide rails, stopping the elevator securely. This system does not rely on electricity. It's mechanical. So even during a power failure, the braking mechanism can still engage. In other words, if an elevator were ever to fall too quickly, it would grip the rails and stop. Another reason elevators are safe is balance. Most traction elevators use a counterweight system. On one side of the pulley system is the elevator car. On the other side is a heavy counterweight, roughly equal to the weight of the empty car plus half its maximum load. This means the motor doesn't lift the entire weight directly. It only has to manage the difference. The system is balanced, reducing stress and increasing control. If power fails, modern elevators don't drop. They usually stop and activate brakes automatically. Many systems even lower the cabin slowly to the nearest floor using backup power. Safety doesn't stop there. Elevators include speed sensors, door interlocks that prevent movement unless doors are fully closed, emergency brakes, communication systems, backup power features in many buildings. Every layer assumes something else could fail, and designs around it. Elevator engineering is built on redundancy, meaning no single failure should lead to catastrophe. Statistically, elevators are among the safest forms of transportation. Safer than cars. Safer than stairs, in fact. Millions of elevator rides happen every single day around the world without incident. The fear often comes from the lack of control, the enclosed space, the vertical movement. But the engineering behind that movement is meticulous, because buildings grow taller every year, and human trust must rise with them. So how do elevators stay safe? Not by relying on one cable, not by trusting a single motor, but by layering protection upon protection. Mechanical brakes, overspeed governors, counterweights, multiple cables, automatic locking systems. Elevators are designed with the expectation that something could go wrong and prepared for it in advance. That's what real safety looks like, not hope. Preparation. The next time you step inside an elevator and feel that brief flicker of doubt, remember this. You are standing inside a machine refined for over 150 years. a system tested, improved, and built with more safeguards than you can see. The quiet hum beneath your feet isn't risk. It's precision. And the reason skyscrapers stretch toward the clouds is because someone solved the problem of falling long ago. If this helped you ride with a little more confidence, give this video a like so more curious minds can discover the hidden engineering around them. Share it with someone who secretly avoids elevators. And subscribe to Simple Things Why and How, because even the most ordinary ride can hide an extraordinary story. Until next time, stay curious and enjoy the lift.